Once again, good afternoon, my viewers. It's nice seeing you once again. I believe you are doing great, and sure you are enjoying our video. Please, if it's your first time, please don't forget to subscribe so that we can update you with our more videos that we'll be producing or shooting. Now, questions are before us, and as I said, we saw standard questions from exams, external examinations, and they are very real. So please just enjoy it as we continue. Now we want to address this equation applying the formulas of motion or the equations of motion. Question number 1. A car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of the acceleration. What are the things they are talking about here now? First of all, distance. What's the value? 80. So in our equation of motion, we said distance represented by x. The value is what? 80 meters. On a straight road in 10 seconds, this means what? Time. Time is represented by what? T. Which is what? 10 seconds. What they ask us to look for? To what extent is the acceleration? So we are looking for A. So this T, we can replace with what? Small letter T. So which of the equations do we use? What are the equations of motion? Remember, we have V equal to U plus AT. We have V squared equal to U squared plus 2AS. Then we have X is equal to UT plus 1 over 2AT squared. Which of the equations fits into this? That contains the S, contains the T, and contains the A. Now, note what that a car starts from rest. When a car starts from rest, I told you earlier that the initial velocity, which is U, is equal to 0. The fact that it starts from rest has proven that the initial velocity is 0. So that means the velocity of that vehicle when it was at rest, it was 0, which is initial. So which of the equations contain S, T, A, and U? V, no, it has no X. Equation 1 has no S. Equation 2 has no T. Equation 3 has X. It has U. It has T. It has A. So the perfect equation is what? Equation 3. So we are going to use equation 3 to solve this question now. So equation 3 now, what is our X, AT? What are we looking for? We are looking for A. So we are going to substitute that using equation 3. X is equal to UT plus 1 over 2AT squared. This is plus. Please take note so that you don't make mistake with T and the plus. So what is X? X is what? I'm going to use this. X is what? 80. So let's substitute that to the equation. X is 80. So we're having 80 is equal to what? What is U? U is 0 times what is T? T is 10 plus 1 over 2. What is the value for A given? They gave us our A. We are looking for A. That's what we are given. Times A. Then what is our T again, which is 10. 10 squared. So we are going to say 80 is equal to 0 times 10, 0 plus 1 over 2 times 10 squared is what? 100 times A times 10, 100. So we are going to say 80 is equal to what? 2 here 1, 2 in 100 to give us 50. A times 50. So 80 is equal to 50A. So what I'm going to do, divide both sides by what? By 50. So we're going to say 80 divided by 50 is equal to 50A over 50. 50 cancel 50. Our A is equal to what? 80 over 50. So let's divide it. 80 divided by 50. 80 divided by 50 to give us 1.6. So our acceleration is 1.6 meter per second square. Don't forget, the unit is always a meter per second square. So our acceleration is equal to 1.6 meter per second square. So take note. Very simple. Just understand the equations of motion, apply it, and get your answer. So the next one is, the question comes, it says, which of the following dimensions represent impulse? First of all, what is impulse? Impulse is product of force and time. Impulse impulse is equal to F times T, which is Ft. Yes. The unit is what? Newton seconds. So how do we find it here now? So what is the dimension of force? Dimension of force, F is equal to what? MLT minus 2. What's the dimension of time? Time is always T. So let's multiply them. So we're going to have F times T, which is going to be MLT minus 2 times T. So then we're going to have MLT minus 2 plus 1, because remember this is 1, it's carrying 1. So it's going to be what? MLT minus 2 plus 1 equals minus 1. So that's the answer. So when you come in now, what's the dimension now? The dimension of the impulse is D. Impulse is equal to, yes, this dimension for impulse. That's relation to question number 2. So please understand the dimension. Once you understand the formulas, you're going to get the dimension. You won't be confused. Then the last question, which is number 3. A body accelerates uniformly from rest at 2 meters per second square. 2 meters per second square. You know, they didn't indicate that the distance. They just made it known to us that this is acceleration, and the acceleration which the body starts from rest is 2 meters per second square. Now A is equal to what? 2 meters per second square. Yes. Now calculate its velocity when it has traveled a distance of 9 meters. They gave us x, 9 meters. So what are we looking for? Velocity. Yes. So let's come back to equation 1 now, but note that the vehicle starts from rest. Once it starts from rest, the initial velocity u is always equal to 0. So which of the equation now has a x, v, and u? A, x, v, and u. This one has a, it has no x. This one has a, it has x, it has v, has u. So equation 2 is the perfect equation. So equation 2, which is v squared is equal to u squared plus 2as. What are we looking for? The v. We're looking for v. We're asked to look for what? The velocity. So now v squared is equal to u squared, which is what? 0 times plus 2 times what is a? 2 times what is x? 9. So v squared is equal to 0 squared is always 0. So we have 2 times 2 times 9. It will give us 2 times 2 to give us 4. 4 times 9 to give us 36. So when you take the square root of both sides, we have v is equal to square root of 36. So v is equal to what? 30. Square root of 36 will give us what? 6 meters per second. So that's it. So the velocity, when it has traveled a distance of 9 meters, is what? 6 meters per second. So that's it. Very simple, straightforward. I told you physics is a very simple course. It's a very simple subject once you understand the formula. So stay tuned as we upload more questions and give you more formulas, make physics very simple for you. Thank you very much, my viewers. Don't forget to like and subscribe so that we will update you. Share with your friends and colleagues. See you now.